In this problem, we're given the sum or difference of three logarithmic expressions. Our job is to rewrite the entire expression as a single logarithm. Before I can begin the problem, you should look at the log properties that are necessary to understand in this problem. There are three. The first of which says as long as the base on your logarithms match, as ours does, there's no base written, so I'm assuming that it's base 10. Then this property says if you have the log of some quantity and you're adding it to a log with the same base of some second quantity, you can write that expression as a single logarithm right here, as long as you take these two arguments and find their product, x times y. As you can see, we almost have this property right here. We have the log of some quantity and we're adding it to the log of some second quantity. And here it's interesting to note that where you see the letter y here, we actually have the entire expression 3x squared plus 1. So in my problem, when I see 3x squared plus 1, I'm going to think of that entire quantity as just the letter y, and I can think of this as my log y in this property. Then as a second property, if you have the difference of two logs rather than the sum of two logs, meaning the logarithms are being subtracted, as long as the bases are the same, you can combine them into a single logarithm of the same base by taking the argument of the first logarithm and dividing by the argument of the second logarithm, so x divided by y as shown here. This property will be used in this problem because I have a subtraction right here. Notice, however, I cannot use either of these two properties until I get the coefficient on the logarithm to be a 1. So a few seconds ago I said that notice we almost have this situation, and what I meant by that is we don't actually have this situation because we have the coefficient 7, 5, and you can either think of this as positive 3 or negative 3. Either way, none of my coefficients on the logarithm are 1. So that's what the third property does. The third property says if you have a logarithm with some coefficient n, so in this case n is 7, here it's 5, here it is 3 or negative 3, and you want it to be a 1, what you can do is you actually can move that coefficient up as an exponent on the entire argument of the logarithm. So it would be x raised to the n, and notice that my coefficient would now be a 1. So the first step in doing this problem before I can apply property 1 or property 2 is to move those coefficients up as exponents. Be careful when you move them up that the exponent gets applied to the entire argument. So for example, when we move the coefficient to 5, the 5 will be the exponent on the entire argument of the logarithm. This argument's 3x squared plus 1, so all of that will be raised to the 5th power. So doing that, I'm going to write log. I'm going to move the 7 up as an exponent on the x. So in my case, n is 7. I will move it up, and this will now read log of x to the 7th. As a side note, notice that it's common when your argument on the logarithm is a monomial, meaning it's just one term, that we don't put parentheses. If I had to put parentheses, it would go here. The reason I'm pointing that out is I have seen some people misread the original problem as that the parentheses go here and that there's implied multiplication in here. I'm going to copy the addition now, and I'm going to do with the 5 what I just did with the 7. The 5 is a coefficient, and this property says that that coefficient can be moved up as an exponent as long as it's an exponent on the entire argument. So when I move the 5 up, the 5 is actually going to be the exponent on the entire quantity in parentheses, and as I've been saying in this video, that quantity inside the parentheses, the input into the logarithm, is often referred to as the argument of the logarithm. So I'm going to write this as log. I'm going to copy my entire argument, 3x squared plus 1, and I'm going to be raising that entire argument to the number 5. Here you have a choice to either move the entire negative 3 up as an exponent, and then you'd be left with an addition symbol because you moved the negative, or what's more commonly done is leave the subtraction here and move just the 3 up as an exponent on the quantity in parentheses here, and doing so that would look like this. Now that my logarithms all have a coefficient of 1 in front or negative 1, just like my properties, you can see that the coefficient here was 1, 1, 1, and technically negative 1 if you want. And now that those coefficients are all 1, or if you want to think of this as negative 1, I can apply the first two properties, and I'm going to attempt to do it in one step. I technically could do two. If you look at the properties in the right way, you see there's kind of a summary to be shown. If you notice that whenever the coefficient on the logarithm is a positive 1, like here, here, and here, then when you use the log properties, that the argument of the logarithms whose coefficient is positive 1 end up in the numerator of the fraction of my single logarithm here. So if you had to think of this as a fraction, you could think of this as over 1. Notice that x and y are both in the numerator. This is because the coefficient on the logarithms are positive. Same thing here. The coefficient on this logarithm is positive 1, and my argument x ended up in the numerator. The only circumstance for which my argument of the logarithm ends up in the denominator is when the coefficient is negative. So when the coefficient is negative 1, the argument, in my case y here, ends up in the denominator. Just seeing the summary of these two properties leads me to believe that I could skip a step, and I will add this step in a minute, but for now I'm just going to say that eventually you would get a single logarithm of some quantity for which you'll have some expressions in the numerator, some in the denominator, and it would be just a matter of picking those pieces out now. For example, this logarithm has a positive coefficient of 1. This logarithm has a positive coefficient of 1. So I will be taking this and be writing it in my numerator, and I will be taking this, which is the argument of this logarithm, and writing it in the numerator. And then, because my last logarithm here has a negative coefficient, you could think of it as a negative 1, then this argument will be copied into the denominator. Now let me clear this up a little bit, and I will do just that. Notice it's not necessary for me to put parentheses around the quantity x cubed minus 1, because a division bar is a grouping symbol in itself. So you can either write your answer with the parentheses in the denominator, that's fine, or you can leave them off. Notice that I started with a base 10 logarithm on all three terms, and I end with a base 10 logarithm in my simplified answer. And now I've rewritten the expression as a single logarithm. If your problem involved any base other than 10, you would have to write that base on each of these steps, and they would have to match. If you had a base 10 problem and a base 9 problem, for example, you would not be able to use these properties. As you notice, the properties use the letter B in all locations, indicating they have to be the same. Now in a second, I'm going to erase this and show you the step that I technically skipped when going from here to here. At some point in the video, however, I want to point out that there are no properties for the log of x plus y or the log of x minus y. Notice that my sum properties have two logarithms being summed together, not a single logarithm of two quantities being added together, meaning it's the sum of the logs, not the log of a sum. I have the log of a quantity plus another quantity, but there's no property that allows me to rewrite that in any way. Here I want to show you that you should actually break this into two steps. Let's look at this piece here and work on just it, and then we would just be copying down the third term of this problem. And here I will point out that I have the sum of two logarithms, and here's the property for the sum of two logarithms. So you are to match up this variable x with x to the 7th, which is a little abstract when we're using the variable x here and it represents x to the 7th. But mind you, you could use this property where we put an a and a b here, and it would just read the log of a plus the log of b would be equal to log of the quantity ab. So you could think of it as you're replacing whatever variable we put here with x to the 7th, and here you're replacing whatever variable you have here with this entire quantity. So in the original statement, this would be my x, this whole quantity would be my y. So I'll be copying the x to the 7th, which in this form would just be the letter x, and I'll be copying this entire quantity, and this entire quantity matches up with the letter y, so I need to put that in the parentheses as being multiplied by my first argument here, and then I would just copy down my third term, which now becomes my second term in this problem, and I'll copy the subtract symbol down. Now I have three terms written as two terms, so I have two logarithms. I'm still needing to write it as a single logarithm, so I need to do one more property. And now I can think of as I have the difference of two logs, and it says here that the difference of two logs can be combined into a single logarithm as long as I take the argument of the first logarithm and divide by the argument of the second. So I will write down a single logarithm. If your base is other than 10, don't forget to keep copying the base. And then the property says that I take the first argument x and put it in the numerator, and my first argument is this entire quantity here where I circled in red. And then I take the argument of my second logarithm, which would be the letter y in this property, and it goes in the denominator of my fraction, so I'll put one long fraction bar here, and I will copy this argument in the denominator with or without parentheses, because a division bar is a grouping symbol and it implies that we're dividing by the entire quantity. You need not put parentheses. If you'd like, you could put one large set of parentheses here, but it wouldn't be necessary.